So we're going to do exactly the same problem now, but we're going to use 4 rectangles as before, and left-hand endpoints this time though, instead of right-hand endpoints. So what we're trying to do is approximate the area of this shaded region, or the region I'm indicating here, A. It's the region between the x-axis and this graph of y equal x squared. On the interval on the x-axis, on the interval from 0 to 2. That is between the vertical line x equal 2 and x equals 0. So same problem as A, approximate this area, but now we're supposed to be using 4 rectangles as we did before, but left-hand endpoints. So the first step is the same. I want to partition this interval from 0 to 2 into 4 equal parts. So again, as before, delta x is the length of the whole interval, 2 minus 0 or 2, divided by 4. So that's 1/2. So I go from 0 to 1/2. So I have 1 1/2. I have 2 1/2, which is 1. I have 3 1/2. And then I have 4 1/2, which is 2. If you divide the interval between 0 and 2 in 4 equal parts, the width of each subinterval will be 1/2. So all the tick marks will just be moving over to the right, 1/2. Okay? I draw a vertical line through each one of these tick marks until it intersects my graph. And I need to draw the heights of the rectangles. I use the left-hand endpoints. So this first subinterval is from 0 to 1/2. The left-hand endpoint is 0. So f of 0, which is 0 squared or 0, by the way, is the height of this first rectangle. This first rectangle is basically non-existent, right? Because it's got a height of 0. I'm just drawing this horizontal segment here for emphasis. The rectangle is, over this first subinterval, is non-existent because its height is the left-hand endpoint of the subinterval 0 to 1/2. And its height's determined by the left-hand endpoint. Its height specifically is f of the left-hand endpoint. But f of the left-hand endpoint's f of 0, which is 0 squared or 0. Okay, the second subinterval goes from 1/2 to 1. The left-hand endpoint is 1/2. So I let f of 1/2, which is the height of this point, be the height of my rectangle over the second subinterval. The third subinterval is 1 to 3/2. The left-hand endpoint's 1. So I let f of 1 be the height of this third rectangle. And the fourth subinterval, 3/2 to 2, the left-hand endpoint is 3/2. So f of 3/2, where the vertical line through 3/2 meets the graph, that's f of 3/2, is the height of this last rectangle. So I'm going to shade in the 4 rectangles that I'm using for this is called a Riemann sum. A Riemann sum is just the area of these rectangles. Okay. What's L4? Well, it's the area of the first rectangle That's the height, which is f of 0, times the width, which is 1/2. Notice that's going to compute to 0, plus, what's the area of this rectangle right here? Well, the height is f of 1/2, because that's the left-hand endpoint, 1/2. The width is 1/2. Where am I getting this width? Right here. Each one of these subintervals is a 1/2 inch, or a 1/2 unit. Third subinterval. Left-hand endpoint's 1. So the area of this third rectangle is f of 1 times a 1/2. Height times width. And finally, the fourth subinterval, left-hand endpoint is 3/2. So the area of that rectangle is f of 3/2 times 1/2. Let's compute this. F of x is x squared. So let's see what number we get there. I get an 1/8 plus a 1/4 plus 9/4 times a 1/2. That's 9/8. So I get 1/8 plus 2/8 plus 9/8. That's 12/8. If I divide top and bottom by 4, that's 3/2. So L4 is 3/2, or 1.5 units. So we're saying the exact area under this curve is approximately 3/2. But this 3/2 is clearly what? An underestimate. It's way too little. So in the previous example, using right-hand endpoints, the area was approximately 15/4. That was almost 4. That's an upper bound. A lower bound for the true area is 1.5. So the true area is somewhere between 1.5 and 15/4.